5. Stereochemistry of SN1 reactions. Since hybridization of positively charged carbon atom in a carbocation is sp2. Carbocations are planar around positively charged carbon. Hence, in the second step, nucleophile can approach positively charged carbon from both sides. That is, from the front side as well as from back side. Therefore, in the case of optically active alkyl halides, the product formed will be a racemic mixture. That is, half of the molecule have a same configuration as that of a reactant, and the remaining half have a opposite configuration. Hence, the product is expected to be a racemic mixture. But experimentally it is found that concentration of product having a opposite configuration to that of a reactant is slightly excess than the product having same configuration as that of a reactant. Hence, it is more accurate to say that only partial racemization take place during SN1 reactions. The nucleophile can crowded behind asymmetric carbon atom even before the departure of a leaving group. Hence, concentration of a product having opposite configuration will be slightly higher than the product having same configuration as that of a reactant. For the front side approach, the leaving group must be departed from asymmetric carbon atom. So there will be a time gap, and hence concentration of product having a same configuration will be slightly lower. Hence, partial racemization take place during the course of a SN1 reaction. So consider an example: 1-chloro 1-phenyl ethane. Here the first carbon atom is asymmetric. This represents R isomer of 1, 2, 3. 1, 2, 3 runs in clockwise direction. Sorry, it is R isomer of 1-chloro 1-phenyl ethane. When it is treated with aqueous solution of sodium hydroxide, it gives a mixture of R and S isomers of 1-phenyl ethanol. This is R isomer. This is S isomer of 1-phenyl ethanol. Here 1, 2, 3 runs in clockwise direction, so it is R isomer. In order to find the configuration of the second product, carry out mutual interchanges between phenyl and methyl group and between hydrogen and OH group. Now hydrogen is pointing away from the observer. Now 1, 2, 3 correspond to S configuration. So the product is R and S isomers of 1-phenyl ethanol. One compound is dextrorotatory and other is levorotatory. So the product is a racemic mixture. This is formed by front side approach of OH minus ion. This isomer is formed by rear side approach of the nucleophile, that is OH minus. In order to have a front side approach of nucleophile, this chlorine should be removed from the molecule as a chloride ion. Then only OH minus can approach this carbon. Rear side approach is more easier. The OH minus ions can be crowded behind this carbon atom, that is from a direction opposite to Cl. As soon as chlorine depart, OH can make a bond with this positively charged carbon. Hence, concentration of product having opposite configuration. In this example, concentration of S isomer will be slightly greater than the concentration of R isomer. Hence, partial racemization take place during SN1 reactions. If R and S are formed exactly in 1:1 ratio, then it is called a racemic mixture. Experimentally, it is found that concentration of product having opposite configuration is slightly greater than the product having same configuration with that of alkyl halide. The mechanism of reaction involves two steps. In the first step, the alkyl halide undergo dissociation of a carbon halogen bond to form a planar carbocation intermediate. Hybridization of this positively charged carbon is sp2. Therefore, this carbocation is planar around positively charged carbon. This is the rate determining step. Now, in the second step, OH minus combines with this positively charged carbon atom of carbocation intermediate. It is a planar species. OH minus in the second step can approach from the front side. Or OH minus can approach this carbon atom from the rear side. Rear side or back side. This is path 1, this is path 2. Hence, a mixture of products are possible. Once OH minus make a bond with a positively charged carbon, hybridization of the central carbon become sp3. That is, groups are distributed tetrahedrally around this carbon atom. In the front side approach, OH minus occupies at a solid wedge position. So this is R isomer of 1-phenyl ethanol. This is formed from carbocation through front side approach of nucleophile. In the rear side approach, the other isomer is formed. Here the position of OH minus is at dash wedge bond. So this isomer is S isomer of 1-phenyl ethanol. This is formed from path 2 or a rear side approach of a nucleophile. So during a SN1 reaction, both retention of configuration and inversion of configuration take place. In a chemical reaction of enantiomer, if reactant and product have same configuration, both having R or both having S, then it is called retention of configuration. If reactant and product have opposite configuration, then it is called inversion of configuration. Inversion of configuration. Retention of configuration and inversion of configuration take place during SN1 reactions. In SN2 reaction, complete inversion of configuration take place, whereas in SN1 reaction, both retention in configuration and inversion in configuration take place. So once again repeating, stereochemistry of SN1 reaction. The intermediate carbocation is planar, therefore nucleophile can approach positively charged carbon from both sides, giving a mixture of products having both R configuration and S configuration in the case of optically active alkyl halides. The product is expected to be a racemic mixture, but in actual experiments it is found that concentration of product having opposite configuration is slightly greater than product having a same configuration as that of a reactant. Hence, partial racemization take place during a SN1 reaction. Both retention in configuration and inversion in configuration take place during SN1 reactions.